This video will give you a couple more examples that we did not have time to do in class of solving substitution or solving systems of equations using elimination. So I'm going to scroll down to number 5. Oops, actually I guess that's on the next page, sorry. Here we go, number 5. Let's solve this system of equation using elimination. Now the first thing I want you to notice about this is that they're not quite in standard form, this second equation, because notice that the x term is second and the y term is first. To solve a system of equations using elimination, we want to either be able to add or subtract the two equations so that the x term or the y term drops out. So we want to get it in the right shape to start with. So what I'm going to do is just rewrite the second equation so that the x term is first and then the y term is second. So the first equation, I'm not doing a thing to it, just rewriting it. 5x minus 2y is equal to negative 10. And then the second equation, I'm just going to turn these terms around. Put the x term first, so that would be 3x plus 6y is equal to 66. All right, now if you look at our two equations, right now if I were to add the two equations together or subtract the two equations, neither the x nor the y will drop out. But notice, take a look at these y terms. If this coefficient were a negative 6 instead of a positive 3, then when I add the two equations, the y terms will drop out. So what we're going to do is I'm going to take this first equation, and you can do anything you want to an equation as long as you do the same thing to both sides. So I'm going to multiply both sides of the equation by positive 3. That way the coefficient of y will be negative 6. So taking the first equation, I'm just multiplying both sides by positive 3. Make sure whatever you do to one side of an equation, you do the same thing to the other side. When students are doing elimination problems, that's the most common mistake, is that they forget to do the same thing to both sides of the equation. So when I do that, now my new first equation is now going to be 15x. I got that by distributing the 3. Now I'm going to take 3 and multiply it by negative 2y, so that would be negative 6y. Okay, why is this a negative 6? Because I was taking positive 3 times this negative term. A positive times a negative is a negative. And then on the right, negative 10 times positive 3 will give me negative 30. All right, the second equation, I'm just going to rewrite. It has not changed a bit. But notice now, if you look at our y terms, one has a negative 6 for coefficient and the other has a positive 6 for coefficient. So now when I add these two equations together, these terms are going to drop out. 15x plus 3x will give us 18x, and negative 30 plus 66. And let's think about this. If you are at negative 30 on the number line and you add 66, you're going to move to the right past 0, and you're going to end up at positive 36. Okay, and then the last step to solve for x, I'm going to divide both sides by 18, and x is equal to 2. So that is half of our solution. Remember, we're looking for an ordered pair. We're looking for an x and a y that will satisfy both of these equations at the same time. So now that I have my x, I can go back to either equation. It doesn't matter which one, and where I see an x, I'm going to replace it with a 2. I think I'm going to use the second equation and just rewrite it, except instead of writing x, I'm going to write a 2 there. So I would have 6y plus 3 times 2 is equal to 66, or 6y plus 6 is equal to 66. Now to solve for y, I'm going to subtract 6 from both sides, and we'll get that 6y is equal to 60. And then when we divide both sides by 6, y is equal to 10. So our solution then would be the ordered pair. Remember, we're looking for the coordinates of the point where these two lines would intersect. The x value is 2 and the y value is 3. Oh, whoops, the y value is 10. Sorry about that. Let me fix that really quick. All right. Okay, y value is 10. Sorry about that. All right, so there's our solution to number 5. Now we're going to go ahead and work number 3 as well. Let me scroll down a little bit. Now let's take a look at this equation. Okay, once again, notice that the equations aren't quite in the right form. I'm going to rewrite the second equation. I want my x's lined up and my y's lined up. So the first equation will be unchanged. negative 9x plus 5y is equal to 1. And then I'm just going to turn these terms around. The positive 3x will go first, and then the negative 2y will go second. So I'm going to write minus 2y, and that's equal to 2. Now, look at these two equations. If I were to either add the two equations or subtract the two equations, neither the x nor the y would drop out. But if you look at the x terms, if this coefficient were just a positive 9, if I could make that a positive 9, then when I add the two equations, then the x's would drop out. So let's do that. Let's make this a positive 9 by multiplying both sides of this equation by 3. Make sure whatever you do to one side of the equation, you do the same thing to the other. So rewriting the first equation, I have negative 9x plus 5y is equal to positive 1. And then the new second equation, when I distribute 3 on the left, I'm going to have positive 9x, and then positive 3 times negative 2y would give me negative 6y, and that's equal to 2 times 3, or 6 on the right. Okay, so now let's add these two equations. By the way, you can either add the two equations or subtract the two equations. Do whatever you need to do that will make one of the variables be eliminated. So I'm going to add, because I have a negative 9 here and a positive 9 here, negative 9x and positive 9x cancels. What about this positive 5y plus, remember I'm adding a negative 6y. Well, if I'm taking positive 5 and adding negative 6 to it, that's going to give me a negative 1y, or just the opposite of y, is equal to, now remember I'm adding, 1 plus 6 is 7. Now, we're not quite done because we haven't found y. Y is not by itself. We've got this negative in front of it. So what I have found is the opposite of y. If the opposite of y is positive 7, then y must be negative 7. Okay, another way you could think of that is there is an invisible 1 here. The coefficient of y is negative 1. You could also divide both sides by negative 1 to get that y by itself. All right, so we're not quite done. We still need to go back to either equation, and where I see a y, I'm going to replace it with negative 7. I'll just use this equation. Doesn't matter which one you use, you'll get the same value for x either way. I'm going to rewrite this equation, except for where I see a y, I'm going to put a negative 7. So we'd have negative 2 times negative 7, just replacing that y with negative 7, plus 3x is equal to 2, or that would be positive 14. I'm taking a negative times a negative, so my product is positive. Positive 14 plus 3x is equal to 2. Let's subtract 14 from both sides. All right, and we get 3x is equal to, now if I have $2 and I lose $14, I'm not going to go in the hole. I'm going to end up at negative 12. And then finally, to solve for x, I'm going to divide both sides by 3. X is equal to negative 4. All right, so our final solution then, let's write it in the form of an ordered pair, because graphically what we have just found is we have found the coordinates of the point where these two lines would intersect each other. That ordered pair would be negative 4, negative 7. All right, if you have any more questions, be sure and ask me tomorrow in class.